This is Math 3 6.5 notes. That's Math 3, Unit 6, Lesson 5. The title is Rational Exponents. Please make sure you put your name here. If you do not put your name, you are not going to receive credit. So make sure that is there. We are going to be simplifying, and these are problems you dealt with in Math 2. Again, they're a little bit harder because you're now in Math 3, but the first few should feel like review. 49 to the 1/2. You learned back in Math 2 to write this as a radical, 49, and the denominator, the 2, goes as the index, and the exponent, the power of 1, goes as your exponent. Now, whether you write it inside or outside doesn't matter. You can write it like that. You can write it like that. I'm just going to leave it on the outside. It's easier if you do the radical first and the exponent after. The square root of 49, we usually don't write the 2, but it's okay to write it. The square root of 49 is 7, and 7 to the first power is just 7. Okay, number 2. 27 raised to the 2/3. Again, we're going to do the same thing. We're going to convert it to a radical. 27 stays inside. The denominator becomes the index, the number at the top, the numerator becomes the power. Inside or outside doesn't matter. It's easier on these when you're simplifying to put it on the outside and simplify the inside first. Cube root of 27. 27 is a perfect cube. I hope you have it memorized by now. If not, this is 9 times 3. This is 3 times 3. So you have the cube root of 3 times 3 times 3, all of this squared. It's easier if you just have it memorized. The cube root of 27 is 3, and 3 squared is 9. All right, I'm eventually going to assume you have the cube root of 8 memorized, the cube root of 27, the cube root of 64, the cube root of 125, and so on. Okay, number 3. 16 raised to the negative 3/2. Now, when you have a negative exponent, here is what you're going to do. You're going to move it to the denominator. That's what negative exponents do. They move it to the denominator. So 1 over 16, and my apologies, this should not flip. That should stay 3/2. The only thing that changes is that negative becomes positive once I move it to the denominator. 16 moves to the denominator, negative 3/2 becomes positive 3/2, so it's 1 over radical 16, the index is 2, the exponent is 3, and it's easy if you do the radicals first. Lucky for us, 16 is a perfect squared, and the square root of 16 is 4, but don't forget, I still have to cube it. Okay, moved it to the bottom, 3/2 became positive. Change this to the square root of 16 cubed. Square root of 16 is 4, and 4 to the 3rd is 64, so 1 over 64 is the answer. Not negative 64, 1 over 64. Don't let that negative exponent think you're going to end up with a negative answer. That's not the case. Number 4, 81 to negative 1.25, and you will have a few of these on the assignment. So this becomes 1 over 81 to the positive 1.25. Moves to the denominator, 1 over 81 raised to the 1.25. Now, what does that mean? 1 over 81, that's 0.25 is 1/4, right? 0.25 is 1/4, so 1 and 1/4. What I'm doing is I'm converting it to a fraction, because I don't know how to work with these decimal exponents, but I know how to work with fractional exponents, rational exponents. Okay, 81 is going to stay. 1 and 1/4 is 4 5/4. Remember, you do 4 times 1 plus 1. That was something you learned in elementary school. 1 and 1/4. 4 times 1 plus 1 is 5/4. And then now we're going to do what we do. 1 over radical 81. 4 is the index, 5 is the power. 81 is a perfect fourth root. The fourth root of 81 is 3. You can break it down and figure that out. It is. The fourth root of 81 is 3, and you have 3 to the 5th power. 1, 2, 3, 4, 5. Threes is 243. So 1 over 243 is the answer. Okay, number 5. 5 raised to the 1/2 times 5 raised to the 1/2. These you did last year as well. Remember, when you're multiplying, you add the exponents. The base is going to stay 5. You're not going to multiply the 5 times 5 to get 25. The base will stay 5. So it's going to be 5 raised to the 1/2 plus 1/2. You add the exponents, the bases stay the same. X times x is x squared, not 2x squared, just x squared. 1/2 plus 1/2 is 1, and 5 to the 1st power is 5. Okay, next one. 81 raised to the 1/2 over 81 raised to the 1/4. Remember, when you are dividing fractions that have like bases, you raise them, you subtract their exponents. I'm going to repeat that. When you're dividing like bases, you subtract the exponents. I'm going to write that over here. 1/2 minus 1/4, and it's going to be 81 raised to whatever fraction or whole number I get over here. This is going to stay 1/4. Multiply top and bottom by 2, you get 2 over 4. 1 times 2 is 2. 2 times 2 is 4, and the reason I did that was to get them to be common denominators. 2/4 take away 1/4 is 1/4. So I have 81 raised to the 1/4. I'm not done, but I have 81 raised to the 1/4. Okay, now I'm going to change it to a radical, and it looks like this. The 4th root of 81. I don't need to write the power of 1. It's okay if you do, but it's not necessary because a power of 1 is equivalent to like multiplying by 1. It doesn't change anything. Okay, so I'm going to erase that 1. It's okay if you do, leave it there, but it's not necessary. Okay, 4th root of 81. 81's a perfect cubed. The 4th root of 81 is 3. Break it down. I don't have a power there, so it's just 3. If you left the power, it would be 3 to the power of 1, which is still 3. Number 7 is 36 to the 5/2 raised to the 1/5. Again, remembering from last year, a power to a power, you multiply. So you don't multiply the bases, just the powers. You're going to do 5/2 times 1/5. Which is 5 over 10, which is 1/2. You could cross reduce and still get 1/2. Okay, so this is kind of our little thinking work is what's going on here. So I have 36 raised to the 1/2 power. Where did I get the 1/2 power? I did 5/2 times 1/5, multiplied, reduced. 36 to the 1/2 is equivalent to square root of 36. I'm not going to write the numbers in there this time because you should know a power of 1 is not necessary and an index of 2 is not necessary, because if I leave it blank, it's implied to be the square root. The square root of 36 is 6. Number 8, 64, x to the 6th, y to the 9th, parentheses, 1/3. Okay, I'm going to do the same thing I did on this previous one, but I do have to distribute the 1/3 to all 3 chunks, 3 pieces. Now, why is it okay to distribute? Just the other day in class, I said don't distribute the exponent. You don't distribute the exponent when your base is a binomial or larger. If it's a binomial, you write it twice and double distribute. If it's a monomial, meaning it's just one term, there's no plus or minus signs, it's okay to distribute. 64 to the 1/3, x to the 6th to the 1/3, and y to the 9th to the 1/3. Okay, now if you want, you could put a 1 there. 1 times 1/3 is 1/3, is what's going on there. Okay, I am going to clean this up. This becomes radical 64. The index is 3. The power is 1. It's not necessary. Over here, I'm going to multiply my fractions with whole numbers. 6 times 1/3 is 6 over 3, which is 2, or you can cross reduce. So x squared. Now I'm going to do this one. 9 times 1/3 is 9 over 3, which is 3 again, or you can cross reduce. So y to the 3rd. And then this is what we're going to clean up. You want to eventually have this one memorized. The cube root of 64 is simply 4, x squared, y cubed. 4 x squared, y cubed. And number 9, parentheses 64, x to the 12th, y to the 1/2, all raised to the 2/3. Because there's no plus or minus signs, I am allowed to distribute the exponent. There's a power of 1 there. 64, 1 times 2/3 is 2/3. X to the 12th raised to the 2/3, I'll multiply those in my next step. Y to the 1/2 raised to the 2/3, I'll multiply those on my next step. Okay, radical 64, index is 3, power is 2. I'm going to put my little thinking bubble over here for my multiplication. You could do the multiplication in your head. I'm at least showing you the work. 12 times 2/3. I'm right here. 12 times 2/3. I'm going to cross reduce this one because I haven't on any of the other ones. 3 divided by 3 is 1. 12 divided by 3 is 4. 4 times 2 is 8. So I have x to the 8th. And then I'm going to make this a little bit bigger to get my other numbers in. I have 1/2 times 2/3. 1/2 times 2/3. I can cross reduce the 2's. 2 and 2 are gone, so I'm left with 1/3. Now if you wanted to, you could do it the way I did the other ones, where I multiplied and then reduced. So this is y to the 1/3. Okay, we're going to clean this up. Cube root of 64 is 4. We've done that before already. Cube root of 64 is 4, but 4 is still squared. X to the 8th cube root of y. I'm just changing that to radical form. Cube root of y. There's a power of 1 there, but it's not necessary. It's okay if you write it, but it's not necessary. 16 x to the 8th cube root of y. 16 x to the 8th cube root of y. All right, that is it for this lesson. We're done. I'm not going to finish these up in class, which means you're going to turn these in right now as soon as we're done here. Take a picture of just this one page, upload it to Google Classroom, and we'll work on the worksheet together in class.